Good morning, students. Let us look into the next topic called encoders. We know what is encoder. We have seen the introduction of encoders and decoders. Encoder is a device which is used to convert input information into a code. The name itself says it is encoder. So it converts input information into a code. The input information is given in 2 to the power of n input lines. The output would be n output. So you can also say encoder takes 2 per n inputs and gives n outputs. Okay. The reverse operation for encoder is decoder, which converts n inputs to 2 per n outputs. Now, to design this encoder, where the encoder is used, it is used in data compression, signal processing, and so on. So, encoder plays a crucial role in digital logic design or by converting data into a coded form. So, the major objective of encoder is to convert data into a code. This encoder is of 4 types: 4 to 2 encoder, octal to binary encoder, or 8 to 3 encoder, decimal to BCD encoder, and priority encoder. Let us first see 4 to 2 encoder. So when I say 4 to 2 encoder, you all know encoder takes 2 to the power of n inputs and output is n. So 2 per n, here 4, so 2 to the power of 2. So 2 is your output. This is a block diagram for 4 to 2 encoder. There are 4 inputs and 2 outputs. The inputs are named as Y0, Y1, Y2 and Y3. The output is A0 and A1. The major function of encoder, it converts input information to a code. So in encoder, you need to remember that at any time, only one of the 4 inputs will be 1. So at any time instant, only one input can be 1. Others will be 0. So see the truth table of encoder. How many inputs? Y0, Y1, Y2, Y3. So Y0, Y1, Y2, Y3. And how many outputs? 2 outputs, A0 and A1. Now you could understand encoder at any point of time, only one input will be 1, rest all will be zeros. So can you see at first instinct, Y0 is 1, rest is all zeros. In the second instinct, Y1 is 1, rest is all zeros. And the third instinct, Y2 is 1, rest is all zeros. And the fourth instinct, Y3 is 1, rest is all zeros. So what would be the output? Since Y0 is 1, 0, 0, 1, Y1 is 1, 0, 1, Y2 is 1, 1, 0, Y3 is 1, 1, 1. So this is how we need to construct a truth table. You get reverse diagonal. Okay, so now I've got the truth table. Now I need to write the expression for A0 and A1. So to write the expression for logical expression for A0 and A1, now see the A1. What is the place where you have 1 and 1? You have 1 in 2 positions, this place and this place. So in this place where you have this 1, Y2 holds this 1. In this position, Y3 holds this 1. So your A0, A1 will be Y2 plus Y3. A1 will be Y2 plus Y3. Now let us go to A0. A0 has 1s in 2 positions. In this position, first position, can you see Y1 is 1? In second place, Y3 is 1. So it is Y1 plus Y3. So you need to check for the 1 and go to its respective positions. Okay. So A1 is Y3 plus Y2, Y2 plus Y3, A0 is Y1 plus Y3. So after writing the expression, draw the logical expression for it. So how many inputs? Y0, Y1, Y2, Y3. Now what are the 2 outputs? A1 and A0. What is A1? Y3 plus Y2. So I have taken Y3, I have taken Y2. Since it is plus OR gate, when I OR both the Y2 and Y3, I get A1. When I OR both Y3 and Y1, when I OR Y3 and Y1, I get A0. So To design a 2 by 4 by 2 encoder, first you need to write what is an encoder. Then you need to tell encoder has how many inputs and how many outputs. One important point is you need to mention at any point of time only one of these four inputs can be one. Any one of these four inputs can be one. Can you see any point of time? Any one of these four inputs can be one. If y naught is 1, it is 0, 0. Y1 is 1, it is 0, 1. This is how you need to fill the truth table. After filling the truth table, write the logic expression for A1 and A0 and finally finish with your logic diagram. Thank you.